Hello and welcome to the latest edition of Turbo Demos. I'm Nick Hodges, the Delphi Product Manager, and today we'll be talking a little bit further about some structured data types in the Delphi language. Most specifically, we'll be talking about arrays. In Delphi, there are two kinds of arrays, dynamic arrays and static arrays. We'll cover static arrays first because those are the more basic type, and then once we do that, we'll look at dynamic arrays, which can change their size at runtime. Okay, once again, I'm going to start demoing the language with just a simple console application that enables me to keep things nice and lean and concentrate and focus on the language functionality as opposed to the functionality of the framework of ECL or whatever. Okay, so we're going to talk about arrays. And arrays are an indexed collection of elements of the same type. That is, a list of integers or a list of booleans or a list of anything, actually, any type at all. And the way that they are declared is as such. I can declare my array as an array of 0 to 9, 10 elements of integer. I've declared a variable array called myArray that can hold up to 10 integers, and so thus I can do something like this: myArray 0 equals 14, myArray 1 gets 15, myArray 2 gets 44. So you can see I index each individual item in the array with an integer number because the array is indexed from 0 to 9. Now I can index an array with any ordinal type at all, including, say, enumerated types, and we'll see that in a little bit. Now this is called a single dimension array. I can actually declare a multiple dimension array like so. 0 to 9, 0 to 9 of, say, car, and then I can index that array in two different ways. I can index it 0, 0 gets a, or I can index it as well multi-array. I can say 0 and then 1 equal or gets b. Now here's an interesting little sidelight to that. The reason that you can declare this type of functionality here is because another way to declare a multi-array is as an array of arrays. You can declare an array 0 to 9 of array 0 to 9 of car, and these two things are actually functionally equivalent. They won't be actually literally equivalent. Let me save this unit out. One other interesting thing is you can actually have 3, 4-dimension arrays as well. They don't have to be limited to reality, 3-dimensional reality. We can have 4-dimensional arrays. So let's see. I can copy this just for fun. We can do it. I can declare one here. And then I can copy this, put a comma there, and the compiler will take that just fine. Oops, except for it won't take the, call it 4dim array, and the compiler will take that just fine, a 4-dimension array. Now, there may be times when you want to iterate over an array, so we can declare an integer here, I, and now we can use the for statement. For I equals, before we do this, I'll make another note too. You don't have to start your arrays at 0. For instance, you can have some array that is an array from 5 to 12, of integer. So there's no requirement that you have 0-based arrays. And the reason I say that is that it may be that you have to iterate over all the elements in an array. and you have to know the lowest end of the number and the highest end of the number. And it's not always necessarily going to be 0. So there are two special functions that you can call to get the low bound and the high bound of any given array. So you can call the low function, and then this is sum array, to the high bound of the array of sum array, do, begin, end, and then you can, from there, index the array using the variable. Let's do sum array I, like so. And we'll change these values here for you real quickly just to show you this actually works. And of course, sum array 0, that if I compile, it'll get an error. It'll see it means constant value exceeds constant expression. It violates sub-range bounds, and so we have to make sure that these values are all inside the bounds of the array. And let me see. Let me do some work here just to let's fill the whole array up here real quick. I'm just using standard cut and paste here in case anybody wonders. So there's the entries. We can put, I'll change these numbers. Just making up numbers here. And so now, if we run the application, you should see it just lists off the arrays. Whoops, sorry. Now you know why I put these readlines at the end here, to cause it to pause so that we can see the output. There you go. And now you can see that it cranks out those numbers for you in the list, in the array, excuse me. Okay, now there's another way that you can declare arrays. As I said earlier, you can declare an array over a range or a subrange of any ordinal type. Now, we know that enumerated types are ordinal, and therefore we can again declare our classic here, T card suit, club, spade, heart, diamond. And now I can declare a variable called card suit string, which is going to be an array over T card suit of string, like so. And now I can come down and I can fill in that array as you might expect. Club, the index club, which is the first item in the ordinal type T card, in the ordinal enumerated type T card suit, and we'll set that to be club. And then we can say card suit string spade gets spade, and so on. I'll fill them out here while you patiently wait and watch me type so poorly here. Heart gets heart, and I'm going to hold control space, and that gives me card suit string. That helps me. And then actually the IDE should know what the values here are as well, and I can enter diamond using code completion, and I can type in the string diamond here, and now they're all filled out. So now if I do that, so now I can do the interesting I can declare a variable also of type card suit of type T card suit, and I can, let's see, I'll get a begin end statement here. So now the variable I'm going to iterate over is card suit, and I'm going to iterate from the low end of T card suit to the high value of T card suit, and then I'm going to right len out card suit string for the value of card suit, and that will index. Its card suit here is of type T card suit. Card suit string is an array of T card suit types of strings, array over T card suit of strings. So then I can iterate over all the values of T card suit and apply each value into the card suit variable, and then index the card suit string based upon that value. So now run it, and we should see club, spade, heart, diamond. It iterates over the array based upon the ordinal type, and that hopefully will explain a little bit better of what an ordinal type is. An ordinal type is the type that has a specific order and can be iterated over in that order, and you can use that resulting variable as an index for the given array. Okay, that's the basics for static arrays. The other type of array we can deal with is dynamic arrays. That is, arrays whose size is not fixed. It can be declared at runtime and changed at runtime. All of these arrays are static arrays. They are fixed in size. This one's fixed at 10. This one's fixed at 10 by 10. So is this one. This one's fixed at, what, 8 elements. So dynamic arrays can be changed at runtime. And here's how you declare a dynamic array. A din array is simply declared as array of string. You don't have any indexer on it. You just declare it as array of string. Now, however, if you want to use that array, you have to first allocate some memory for it, and you use the setLength function for that. Can't type. The setLength. And the first parameter taken is the name of the array, and the second is the new length. We'll just declare 10 here for this. Now, a couple things about dynamic arrays. All dynamic arrays must be are 0 based. They all start at 0 and go up to the number of elements that you declare it. So this array, din array, will go from 0 to 9 to start with. Dynamic arrays are also always integer indexed. And here's an important thing. Once you allocate memory in Delphi, you should always deallocate it. And so when we're done with the array, we can either set the array to have a value of nil, meaning nothing. Nil is actually a pointer, but we won't get into pointers today, but you can just set it to nil. Or you can call finalize on the array as well. Okay, and of course, once you've allocated the memory for the array, you can just index it as you normally would. Looks like a regular array and works like a regular array from that point on. You can at any time check its length by simply calling the length function on that array as well. That value will return your length array, the length of the array, i.e. in this case it would return 10. And you can also declare dynamic multi-dimensional arrays, din multi-array. You can declare that as an array of integer. And then simply, again, you have to allocate the memory for that. So you would say set length din multi-array, and then here you just would enter 10, comma 10, and you'll see that compiles and works. And of course, finally, just so that you know, you can declare. I'm just going to declare an integer here, say of temp length. There may be some time when you don't know again the size of the array, what it's going to be. Somebody may type in some value. You have a genealogy program, and you type in this person has 5 kids or 7 kids or whatever. So you can store that variable store that value in a variable, and then of course you can call set length din array and just pass in a variable there instead of a constant number. So that's one of the powers of variable arrays, right? Is at runtime they can be any length that you want. You can also change the length of an array by recalling set length on the array again with a different value. Okay, well that wraps up the basics of arrays in Delphi. We looked at static arrays, which are fixed in length and their length is set at design time. And we looked at dynamic arrays, where you can actually at runtime set and change this size of an array. And arrays are useful for holding an indexed group of similar types that are the same. So that wraps it up, and thank you very much. See you next time around.